Namaste, Vanakkam and welcome back to MidhaGuru. If you don't know me by now, my name is Manan and I am the math faculty here. And today we are going to study a very interesting topic that comes under the area of polygons. It is known as the Heron's Formula. Before we begin, do you know how to calculate the area of a triangle? Well, the area of a triangle can be calculated by the formula half into base into height. The base being nothing but the side that the triangle is resting on, and the height being the altitude of the triangle corresponding to that base. But what if we don't have these details? What if we are only given the three sides? Calculating the height may seem very easy, but when you do not know any details, it is a very cumbersome job. So how do we calculate the area of a triangle in which we only know the three sides? Well, in the 10th century AD, a very famous mathematician was born in Alexandria, that was then in Egypt. His name was Heron. He calculated a formula that can be used to calculate the area of a triangle based on its three sides. Well, we'll get into the lesson and you will understand better how this formula works and how it is supposed to be applied in our day-to-day problems. But before we get into the lesson, let us first try and understand what the objectives here are. The first is to understand the approach that was brought by Heron to derive this particular formula. Second is that we will try and calculate the area using the formula. The third is that we will understand its application in day-to-day triangle problems. And the last is that it will help us understand how to calculate area of complex polygons by dividing them into different triangles. Now we come to the formula that Heron derived, which says that the area of a triangle can be calculated by the formula root over s into s minus a into s minus b into s minus c, where s is the semi-perimeter, that is half of the perimeter of the triangle, a is the length of the first side, b the length of the second side, and c being the length of the final side. But what does this mean? Well, now we'll see what it applies. As you can see, we have a triangle in which this side is marked as A, this as B and this as C. To calculate the semi-perimeter, all we need to do is first calculate the perimeter, which will be A plus B plus C, right? So the semi-perimeter will be perimeter divided by 2, or A plus B plus C divided by 2. Now we calculate the value of s minus A, s minus b and s minus c. Then we multiply s by s minus a, multiply s by s minus b and s minus c, and we place a root over this entire multiplication, which will give us the area of this particular triangle. But you may be confused as to why this formula arrived. Well, let's look into its derivation. Coming to the derivation of Heron's formula, you can clearly see a triangle on the board. Let us first mark its vertices as A, B and C. So the side opposite to the vertex A is of length A. The side opposite to vertex B is of length B, and the side opposite to vertex C is of length C. Now as you can see, the altitude has been dropped from vertex A. Let us say that it divides the base A into two parts. This part is x and the remaining part will be A minus x. Before we begin, there are a few things that you must keep in mind to arrive to this derivation. The first thing is that s is equal to A plus B plus C by 2. So 2s will be equal to A plus B plus C. Now 2s minus A will be equal to B plus C, 2s minus B will be equal to A plus C, and 2s minus C will be equal to A plus B. Apart from this, we will be using a few algebraic identities, namely A plus B whole square, A minus B whole square, and the formula of A square minus B square is equal to A plus B into A minus B. Now, if this is a perpendicular to the base, you can see that it forms two right triangles. Let's mark this point as D. Now in triangle ACD, Clearly this is the hypotenuse, so b square must be equal to h square plus x square, this being h. In the same way, in triangle ADB, h square must be equal to the hypotenuse minus a minus x whole square. Now as you can see, we get h square in both the triangles, which means that these two sides should be equal, right? So if we write down here that h square is equal to b square minus x square, now we can equate these parts of the two equations, which will give us that b square minus x square is equal to c square minus a minus x whole square. If we expand this term, we get the equation as b square minus x square is equal to c square minus a square plus x square minus 2ax. When we open this bracket, we get b square minus x square is equal to c square minus a square minus x square plus 2ax. Now, to calculate the height, there is no other way but to calculate the value of this part x. Only then will we able to calculate the value of h. So from this part, as you can clearly see on both sides of the equation, minus x square is present, so we can cancel out these two. Now the remaining equation can be written as 2ax is equal to b square plus a square minus c square, and thus the value of x will be equal to b square plus a square minus c square by 2a. Let us keep this part in mind as it will help us in the further derivation. Now if we apply the value of x to this equation here, we get h square is equal to b square minus b square plus a square minus c square divided by 2a and whole squared. So moving ahead, instead of squaring this term, we can apply the formula a square minus b square is equal to a plus b into a minus b, which will give us that h square is equal to b plus b square plus a square minus c square by 2a into b minus b square plus a square minus c square by 2a. On opening this bracket and applying the LCM, we get h square is equal to 2ab plus b square plus a square minus c square by 2a into 2ab minus b square minus a square plus c square by 2a. Now if we can take 2a common out from both these terms, we get h square is equal to 1 by 4 a square into 2ab plus b square plus a square minus c square into 2ab minus b square minus a square plus c square. As you can clearly see, this is the formula for a plus b whole square, and this is the expansion of a minus b whole square, but minus has been multiplied to all the terms. So we can write down this as h square is equal to 1 by 4a square into a plus b whole square minus c square into c square, as this is in minus, we write minus a minus b whole square. Now instead of expanding these, we can again write it down in the form of a square minus b square here and a square minus b square here as well. We get h square is equal to 1 by 4a square. Inside this bracket, we get a plus b plus c into a plus b minus c. Here we get c plus a minus b into c minus a minus b will become plus b. Now, if from the previous slide you can remember, a plus b plus c was nothing but 2s. A plus B was 2S minus C, and another minus C here. And again, C plus A was nothing but 2S minus B. And C plus B was 2S minus A. If we simplify all this, we get h square is equal to 1 by 4 a square into 2s minus 2c into 2s minus 2b into 2s minus 2a. As you can see, 2 is common here, here and here, and even here. If we take out all the 2's, we get 2 into 2 into 2 into 2. That is 2 from here, here, here and here. And in the rest, we get s into s minus a into s minus b into s minus c. Now, as this is h square, we need to apply square root to this entire equation. We get h is equal to 1 by 2a, 2 into 2 into root under s into s minus a into s minus b into s minus c. Now that we have calculated the height, we can go ahead and calculate the area. As you can clearly see, the base of the triangle was A. So we will apply to the formula that the area of the triangle is equal to half into base into its height. The base being nothing but A and the height being this entire term, that is we can cancel out 2 and we as well can cancel out A, which leaves us with the formula that the area of the triangle is S into S minus A into S minus B into S minus C and a root over this entire equation. So now we have derived the Heron's formula. I know it was a bit lengthy and it involved very long calculations, but it was very fun, right? So now we are going to see the applications of this particular formula. The first application is very clearly calculating the area of triangles in which we know the 3 sides. But the other application is calculating the area of quadrilaterals in which nothing is given clearly. As you can see, AC is the diagonal, but we do not know the length of the diagonal and we do not know the perpendicular distances from the other 2 vertices. What we can do in the place of that is apply Heron's formula to this particular quadrilateral by dividing it into 2 triangles. The first triangle being ADC and the second triangle being ABC. As you can clearly see, B is a right angle, which means that ABC is a right triangle, and we can apply Pythagoras to it to calculate the length of AC. So, AC square is equal to AB square plus BC square. AB being 9, we can write that as 81, and BC being 40, we can write that as 1600. Now we get AC square is equal to 1681. So AC will be equal to root under 1681, which is nothing but 41 meters. So now we know that the length of this AC is 41 meters. Now, as I told you, we divide it into 2 different triangles and calculate the area of each one separately. So, in triangle ABC, A is equal to 9 meters, B is equal to 40 meters and C is equal to 41 meters. The first step is to calculate the semi-perimeter, which we will get as S is equal to A plus B plus C by 2, which will be 41 plus 40 plus 9 by 2, which will give us 45 meters. Then S minus A will be equal to 36 meters, S minus B will be equal to 5 meters and S minus C will be equal to 4 meters. Now to calculate the area of the triangle ABC, we have to apply Heron's formula, which will be S into S minus A into S minus B into S minus C. Instead of doing this whole multiplication, we can just prime factorize all the numbers inside. We get 3 into 3 into 5 into 3 into 3 into 4 into 5 into 4. This 3 into 3 into 5 will be equal to 45, 3 into 3 into 4 will be equal to 36, and 5 and 4. So now we have a pair of 3's, a pair of 5's, another pair of 3 and a pair of 4. So when we open the square root, we get 3 into 5 into 3 into 4, which will be equal to 180 meter square. This is for the triangle ABC. Now in the triangle ADC, the semi-perimeter is equal to 28 plus 41 plus 15 by 2, which will be equal to 84 by 2, which is equal to 42 meters. So S minus A will be equal to 14, S minus B will be equal to 1, and S minus C will be equal to 27. Now to calculate the area of triangle ADC, we get root under 42 into 14 into 1 into 27, which we can write down as 42 can be written as 7 into 3 into 2, 14 can be written as 7 into 2. As we don't need to write 1, we can write 27 as 3 into 3 into 3. Now as you can clearly see, there's a pair of 7's, a pair of 2's and 2 pairs of 3's. So when we open the square root, we get 7 into 7, 3 into 3 into 3 into 3 into 2 into 2. So on opening the square root, we get 7 into 3 into 3 into 2, which will be equal to 21 into 6, which is nothing but 126 meter square. So now the area of this quadrilateral ABCD can be given as the sum of the area of the two triangles, which will be 180 plus 126, which will be 306 meter square. So that's how we apply the Heron's formula on different quadrilaterals by dividing it into two different triangles and calculating their areas by Heron's formula when the different details, such as for a quadrilateral, the length of the diagonal and the perpendicular distance from the other two vertices are not given, or in the case of a parallelogram, the base and the altitude are not given, but only the sides of the parallelogram and the length of one diagonal. So now that we have covered the applications and learned how to apply Heron's formula to different triangles and also quadrilaterals, let us solve a few example problems which will help you understand better how Heron's formula can help us. In the first example problem, it says that a triangle and a parallelogram have the same base and the same area. Just remember that the parallelogram and the triangle are resting on the same base and have the same total area. If the sides of the triangle are 26, 28 and 30 centimeters and the parallelogram stands on the base 28 centimeters, find the height of the parallelogram. The diagram will look something like this. As you can clearly see, this parallelogram is resting on the 28 centimeter base, and we make the triangle in the same way that it rests on the 28 centimeter base according to this part of the question. Now the second part of the question says that they have the same area. For the area of the parallelogram ABCD, we know that its area can be given by base into its height. As we don't know height, we leave it at h, but we know the base, so we can write that down as 28h centimeter squares. Let us leave the parallelogram for now and move on to the triangle. Clearly, in the triangle DCE, we know that A is equal to 30 centimeters. The side B, we can mark the side 26 centimeters, and side C we will take as the 28 centimeter side. The first step is to calculate the semi-perimeter. So 28 plus 26 plus 30 divided by 2, which will give us 84 by 2 or 42 centimeters. So S minus A will be equal to 12 centimeters, S minus B will be equal to 16 centimeters, and S minus C will be equal to 14 centimeters. Now to apply the formula, we will get root under 42 into 12 into 16 into 40. Again, if we prime factorize these numbers, we will get 7 into 3 into 2, 3 into 2 into 2, 4 into 4. As you can clearly see, it's a pair of 4, so we don't need to further prime factorize them. And 14 can be written as 7 into 2. So we have a pair of 4s, a pair of 2, another pair of 2, a pair of 7 and a pair of 3. So when we open this, when we open the square root, we get 7 into 3 into 2 into 2 into 4. On calculating, we will get it as 16 into 21, which will be 336 centimeters square. Now, according to the question, the parallelogram and the triangle have the same area. We calculated the area of the parallelogram as 28h centimeters squares. So, the area of our parallelogram must be equal to 336 centimeters squares, right? So, 28h must be equal to 336, which means h is equal to 336 by 28. On dividing this, we will get 12. That means the height of this parallelogram is nothing but 12 centimeters. So, we solve the problem using Heron's formula. In our next example problem, a rhombus shaped field has green grass for 18 cows to graze. If each side of the rhombus is 30 and its longer diagonal is 48 meters, how much area of grass field will each cow be getting? You know that the area of a rhombus can be calculated by the formula half into d1 into d2. But as you can clearly see, we only have the length of one diagonal and the second diagonal is not given to us. Calculating that is going to be a very hard job. So instead, we can clearly see that the diagonal divides the rhombus into two equal triangles, and we can calculate the area of one triangle by Heron's formula and multiply that by 2 to get the area of the entire rhombus. To go about this, in the triangle, let's say ABD, that is this triangle. Let us take side A as the 30 meter side, side B also as the 30 meter side, and side C as the diagonal, that is 48 meters. The first step must be to calculate the semi-perimeter, which will be 30 plus 30 plus 48 by 2. This will sum up to 108 divided by 2 will give us 54 meters. Now, S minus A will be equal to 24, S minus B will also be equal to 24, and S minus C will be equal to 6. Now, to calculate the area of the triangle ABD, we get root over 54 into 24 into 24 into 6. As you can see, 24 is already in a pair, so we do not prime factorize that. We prime factorize 54 and 6, or we can write 54 as 6 into 9 or 3 into 3 and 24 into 24 into 6. Now you can see a pair of 24s, a pair of 6 and a pair of 3. So when we open the root, we get 6 into 3 into 24. So 18 into 24 will be equal to 432 meter square. But that is the area of only half the rhombus. So the area of the entire rhombus ABCD can be given by 432 into 2, which will be nothing but 864 meter square. Now the question tells us that it is for 18 cows to graze, and we must calculate how much area of grass will each cow be getting. So each cow will get 864 divided by 18, which will give us 4. 18 4s are 72, so we are left with 144, which gives us 6. So each cow will be getting an area of 46 meters square of green grass to graze on. Let us move on to the next example problem. Coming to our next example problem, we have a very beautiful floral design made by 16 tiles which are triangular, the sides of the triangles being 9, 28 and 35 respectively, and we must find the cost of polishing the tiles at the rate of 50 pies per centimeter square. So as you can see, there are 16 different triangular tiles and each of them is congruent to one another. So if we calculate the area of any one of these tiles and multiply that by 16, we'll get the area of this whole figure. So if we name the sides as A as 9 centimeters, B as 28 centimeters and C as the side of 35 centimeters. So kids, what should our first step be to calculate the area? Very good. The first step should be to calculate the semi-perimeter, which will be 9 plus 28 plus 35 divided by 2. We get 72 by 2, which will be 36 centimeters. Now S minus A will be equal to 27, S minus B will be equal to 8 and S minus C will be equal to 1. To calculate the area of this triangle, we apply the formula, that is S into S minus A into S minus B into S minus C. We can write this down as 9 into 4. We can write this down as 9 into 3 and 8 as 4 into 2, and we do not need to write the 1. So now you can see a pair of 9s and a pair of 4s, and 3 and 2 are unpaired, so we'll write that down as root 6. So removing the root, we get 9 into 4 root under 6, which will be 36 root 6 centimeter squares. Now this is the area of only one of these triangles, and as you can clearly see, there are 16 such triangles. So the area of the whole design will be equal to 16 into root 6 into 36, which you will get as 576 root 6 centimeter square. This will be the area of this whole floral design, or the area of all the tiles used to make this floral design. But this is not the end of the problem. We must also calculate the rate of polishing at the rate 50 pies per centimeter square. So the cost can be given as 576 root 6 into 50 pies, or 576 root 6 into 0.5 rupees, which will give us 288 root 6 rupees. To calculate the exact value, you can apply the value of root 6 and multiply that by 288 and we'll get our exact answer. Well kids, we have come to the end of our lesson, but if you have any doubts or there is still something that you did not understand, please let me know in the comments down below, and subscribe to our channel MidhaGuru and join the family today. Thank you.